In this video, I'm going to give you an introduction to the Flames class hierarchy. And as is the case for all of the videos in this series, in this course, I'm going to be referring to the topics in a manual that we refer to as the Flames Development Guide. So you might want to open that up and follow along with me as I present the information. So I'm going to look at one of the first topics in the Flames Development Guide that we refer to as, that talks about the Flames class hierarchy. So here it is. What you have here on the left-hand side are the more abstract classes, and the classes get more specific as you move to the right. So normally this would be a top-down, but because of the number of classes that we have to display here, it's easier to fit on a page if we have it going from left to right. So this is a long list of classes. These are not, of course, all the classes that exist in Flames. Flames has hundreds of classes, and they're all, most of them are internal to Flames, but these are the classes that you need to know about if you're going to develop software that is going to execute by the Flames engine applications. These are the classes that you inherit. You may write some little utility functions from time to time that are not subclasses of these classes, but the things that Flames is going to know about and work with, the classes that Flames will be able to work with, they must inherit one of these classes. So one of your first jobs when you decide to write new software for Flames is to figure out which particular Flames class you're going to inherit, and you'll get part of that information from this video. So let me start from the top here, the top left. One of the most base modeling classes in Flames is the F component class. And again, there's a bunch of other things in Flames that inherit this class, but these are the classes that you need to see for your development. You'll notice that underneath component is fEntity. And fEntity is the parent class of most of the modeling classes right here. There are a few other classes that directly inherit F component, and we'll talk about those later. There's even one class here that doesn't inherit F component, but most of the classes inherit fEntity. In Flames, an entity is a generic object. It's a building block for Flames systems. That could be real-world systems, or it could be internal management type systems. An entity is not a player. We refer to players in this scenario as units in Flames. Most simulations refer to entities as the players, but in Flames, entity is a lower level building block of units and of other things. You'll notice that the fEntity name is within a symbol, oval type symbol that is colored gray. The gray classes are classes that you cannot inherit directly. They're abstract classes that are there to be inherited by other classes, but you would not inherit those directly. The classes in blue and red are the classes that you'll inherit directly in your models. The blue classes are classes that are written in C. And Flames at its core is written in C, and the core classes are written in C. But C classes can be inherited directly by C++. And so the red classes are all classes that are real C++ classes that inherit the Flames classes above them that are written in C. Take a little detour here. You might wonder why it is that we wrote and have Flames written in C. Well, there are a number of reasons. Initially, it was because at the time that we wrote Flames, C++ wasn't a very popular or very heavily used programming language. It wasn't until many years later that C++ became popular, and more importantly, it became stable. And there was a standard stable language that was supported on multiple platforms. So that came quite a few years after we started writing Flames. But even after C++ came on the scene and it was a stable, mature language, we made the decision to not convert the core of Flames to C++. And there are a couple of reasons for that. One of them is that C++ is callable directly only by code written in C++, whereas C can be called pretty much from any language. So if you've been around long enough, you know that there have been some other languages that were popular, particularly in the United States, for doing simulation. There was a period of time, thankfully it was pretty brief, when Ada was the language of choice. That was kind of dictated by our Department of Defense, but eventually people got smart and removed that dictate, and Ada now is not really used very much at all. I'm very grateful for that. But at the time when Ada did need to be used, if we had written the core in C++, we wouldn't have been able to provide native support for Ada. But because we had our Flames classes written in C, it was possible to inherit C classes in Ada and then build models in Ada. So cross-language is a very important part, and who knows what will happen in the years to come. There may be other programming languages. There's already Java, there's already C#, that are other languages that get used. And so the fact that the Flames core, the Flames kernel, is written in C is a very good design decision on our part to be able to provide support for other languages. However, we do recommend that when you write classes for Flames that you write them in C++. C++ is our preferred programming language for doing component class development. All of the models in the starter models, and all, with just a couple of exceptions, and all the models in the tutorial models are all written in C++. All of our manuals are written assuming that you're writing in C++. So we definitely recommend you using C++, and it is the language of choice for doing model development. But another reason that we are using C for our core classes is there are actually some things that are very important to the way we have Flames implemented that C++ just simply can't support. The inheritance and polymorphic calling mechanism of C++ that is core to the design of C++ has some one or two very significant limitations that we don't have when we're implementing inheritance and polymorphism in C++. There's some things that we do that we need to be able to do in C. So that's another reason why we're sticking with C. But again, your model development, we recommend, would always be in C++. So let's go over these classes real quickly. You've already supposed to have listened to the whole course on composing units. So you've already been exposed to all these different types of models, so I'm going to just talk about them briefly. The first model that's really important, first abstract class, is the equipment class, and there are 8 classes underneath F equipment for the 8 different types of equipment models that can be attached to Flames units. COM devices, data processors, which is any kind of a computer, a jammer, which is an electromagnetic jammer for jamming communications or sensing, a platform model, which is what causes a unit to be able to move and gives its observable characteristics. A munition model, which is a subclass of a platform, so every munition model is also a platform. This is the type of model that becomes the platform model when a munition is launched by a weapon system. So the weapon system stays with the unit. When it launches a munition, a new unit is created, and the platform for that unit becomes the munition model. Sensor models, of course, is things that detect other types of equipment, other units. And a subsystem is just a subpart, a subcomponent of any other type of equipment model. So you might model a radar antenna as a subsystem, which is what some of our sensor models do. You might model the engine of a platform as a subsystem. Any one of these particular equipment models may have pieces that you want to model separately so that you can swap them out from the user interface and try out different subsystems in a given scenario. Of all these types of equipment models, a unit can have any number of these attached to it, and you already know how to do that from watching the user videos. The only type of model that a unit can only have one of is a platform model. So there's only one platform model, but any number of the other types of models. So the majority of the models that make up the composition of a unit will be equipment models. The other type of model that's attached directly to an equipment model is a cognition model. And that models the human behavior, really the human cognition of units. Every unit except a munition that's flying or an unmanned vehicle, even unmanned vehicles will have cognition models usually. Every unit will have a cognition model because in the real world, every player is controlled by a human. That's a real important type of model. So units will have equipment models and cognition models attached to them. The other types of models in here are not attached directly to units. They're attached to other equipment models, or they're just environment models. So the attribute models are usually models that are attached to other models, or that are referred to by other models. And you can inherit the attribute class directly to come up with your own types of attributes. Or we have two other subclasses of attributes: formation and signatures. Signatures are observable characteristics of platforms, and formations are just geometry that describes the relative position of units as they move. So those are two known Flames types of attribute classes, and they get attached and used primarily by platforms and sensor models. But you can come up with your own attribute classes, and there are other attribute classes in Flames that are part of the example models that particularly the starter models that inherit attribute directly. It's a pretty handy class for a lot of different purposes. The airspace and atmosphere models are environment models. These don't get attached to units directly. They're used to define the environment. Airspace is the atmospheric properties of a volume in space, and airspace is just a generic word that refers to a point, a line, an area, or a volume in space that has some significance in the scenario. Like maybe the forward line of troops, maybe a low-level transit route, a safe passage corridor, an engagement zone, a missile engagement zone, or a fighter engagement zone. Any type of object that you need to define that provides geometric information to other models would get defined in an airspace class. Feature model, we have it listed here, but you don't have to write feature models for Flames. We don't have any example feature models that come with it. We just list it here because it's another environment model that's pretty important. All the feature models that are used in Flames scenarios are part of the Flames product line. Even though they're models, we provide models built into Flames so that you don't have to write them. So this would be roads and buildings and areas and bodies of water. Flames provides models for the terrain, as well as for things that are embedded in the terrain or lie on top of the terrain. So we just list them there so you know that they're also a subclass of entity. And then, of course, units, you don't inherit those. Units are really very simple classes. They're just containers for other types of models that are attached to them. Units don't have any behavior of their own. You don't build subclasses of units and build different types of units. Instead, you build these types of models, particularly equipment models and cognition models, and they get attached to units, and then that a given unit will have instances of those models, and those models will determine the behavior of the units. And you do that not through code, you do that through the user interface in Forge. There's another type of model that's a subclass of entity. It's a view preference model, and you'll learn more about that in the other course that talks about writing view overlays. So this provides a user interface for specifying parameters that control what gets displayed in a view overlay. But it's also a subclass of entity. Now, the fact that all these models are subclass of entity is really significant. The way that Flames interacts with most models, most objects, is through the methods that are defined by the entity class. So another course in Flames is entity model development. It's a really big course. It talks about the methods of the F-entity class and the attributes of those classes that apply to all of these models. And even though it's a long course, once you learn about that, you have learned a significant amount of what you need to know to be able to write any of these classes. All the user interface, all of the attribute setting, all of the database I/O is the same for all of these classes because they all inherit the entity class. And so that's a really important aspect of this class hierarchy. Another class that is listed here is the service class. That is an advanced class that is designed for you to be able to extend the functionality of the core capabilities of Flames. So almost everything in Flames itself is actually implemented as a service. So, and most of the Flames options are implemented as more than one or more services. So the DIS interface that we have is implemented as a service. The HLA interface that we have, the Checkpoint Restart Manager is implemented as a service. And almost everything inside of Flames itself is implemented as a service. It's a very important class for the internal workings of Flames, and we have exposed it so that you can write services that extend the functionality of the system and allow you to be able to have your code be called as a part of the overall processing loop of the core things that are happening inside of Flames. It's a pretty big class. It's got a lot of power because, again, it's the class that we use for the internal implementation of Flames systems. So there's a whole nother course that we'll cover on how to write services, and there is an example service that's in the tutorial models. The message model is actually it's so simple that it's not inherited by entity. There's no user interface for it, but in Flames, communication is a really big deal. We put a lot of work, have a lot of support for modeling communications explicitly. Classes that inherit the F message class are classes that contain the content of messages that are sent between units, and they're sent by communication devices. Those classes don't have any methods. You don't have anything to implement there, so those are actually written only in C. So that's one of the few types of classes that is written in C. It's really just a data structure that you have to register with Flames, and you put whatever fields in your data structure you want to represent the content of your messages. So this is the overview of the Flames class hierarchy. This particular class hierarchy is actually one of the most valuable things about Flames. It's really hard to build a system. If you read computer science books and you read the masters, the gurus in object-oriented programming, they'll tell you that one of the hardest things to do in designing a good object-oriented system is to get the class hierarchy correctly. When do you inherit? Where do you draw the boundaries between classes? If you draw those boundaries wrong and you set up your inheritance hierarchy incorrectly, you have a system that is a mess, and it can be worse to maintain than the worst set of Fortran spaghetti code. But if you get the class hierarchy right, you can have a really beautiful system that is very easy to maintain, very easy to extend, and has a lot of power. We have worked on this class hierarchy for decades, and we've gotten it right. And we have demonstrated that this class hierarchy is a very good class hierarchy for doing military and transportation system modeling. And that class hierarchy is already there, and you don't have to think about it. You just find the right class that fits the type of model that you want to develop, and you use that class, and Flames already has support for that specific class. This is one of the things that distinguishes Flames from more generic object-oriented execution engines. We have very specific classes for the very specific things that exist in the real world, and there's well-defined relationships between those things, and Flames knows about those things and knows how to execute those things in a manner that's appropriate for modeling real-world functionality. So I hope this is helpful. Eventually, there'll be courses on how to write every one of these types of classes. So we won't go into any more detail at this point. I hope this information is helpful. Thank you for watching this video, and thank you for using Flames.